Alright, quick question to start us off. What if your game console or your VR headset actually worked a bit like a brain? Not metamorphically, I mean the chip itself is wired to behave like neurons firing. That's not science fiction. It's called neuromorphic computing, and it already exists. Here's a simple version. A normal computer chip works on a clock. It's constantly ticking away, processing data, whether anything interesting is happening or not. A neuromorphic chip doesn't do that. It's built from artificial neurons that just sit there quietly, using almost no power, until something worth reacting to actually happens, and then they fire. Or spike. Just like a real neuron would. So, why did I pick this topic? Honestly, because it's one of those technologies that sound like it shouldn't be real yet, but it is. And I wanted to look at it through the entertainment aspect specifically, because that's really where it stops being abstract. Let's start with the basics. In a neuromorphic chip, the artificial neurons talk to each other through little bursts of electrical activity, spikes, as we call it, instead of the constant clocked calculations a normal CPU or GPU runs. A neuron just waits. It doesn't do anything until enough input builds up to cross a threshold, and only then does it fire off a signal to whatever it's connected to. And here's the clever part. The memory and the processing actually sit together on the same core. The chip isn't wasting time or power shuffling data back and forth the way conventional computers do. And that's exactly why a chip like Intel's Loihi can handle something like a live camera feed or a motion sensor with barely any lag and barely any power drop compared to the same job on a standard processor, which, if we think about, is absolutely insane. So, what does this look like in practice actually? A few things. Spiking neural networks running on chips like the Loihi 2 can process video and audio on the fly, which is great for responsive game AI or environments that adapt to you in real time. Then there's event-based cameras. Instead of capturing a full video frame every time, they only report pixels that actually changed. Pair that up with a neuromorphic chip and you get super efficient motion tracking, which is exactly what you want for motion capture or AR overlays. And on the consumer side, this is already happening. Companies like the Emotive or Neurosky make EEG headsets that read your brainwaves and let you influence a game just by thinking. It's called neurogaming, and neuromorphic chips are a natural fit for processing that kind of messy, continuous biological signal efficiently. That's just mind-blowing. Now, for the reality check. What are the limitations? Well, the software tools for building on spiking neural networks are nowhere near as mature as the GPU ecosystems game studios already rely on, which makes it a real hard headache to actually adopt. These chips are still mostly research hardware, expensive, hard to get a hold of, not built into consumer at scale, and even if a studio wanted to use one, converting an existing game engine or AI model to work with spike-based processing isn't a quick job. So what I mean is basically none of today's entertainment software was designed with this kind of event-driven computing in mind. So where does this go? A hybrid setup. Realistically, GPUs still do the rendering, neuromorphic chips quietly handling the sensing, reacting, especially as VR, AR, and brain computer sets get smaller and cheaper. But that raises a real question we shouldn't skip past. Once entertainment systems start reading signals straight from your brain, who owns that data? How's it stored? Could it end up being just to shape how you feel rather than just respond to it? That could feel like a threat. Because as neuro gaming and mood responsive entertainment get more common, those constant and privacy questions need to be a part of the conversation, not an afterthought. Well, and that's neuromorphic computing in entertainment. Brain-inspired chip, quietly waiting, firing only when it matters. That's about it for this talk. Thanks for listening.